Today we're going to cover the section over inequalities in our BJU Press textbook. So let's start with being able to answer this question. How many numbers are less than 4? So we know that 3 is less than 4 and 2 is less than 4. And so if we had to list all the numbers less than 4, we wouldn't be able to. It goes on and on and on. So we have an infinite number of numbers that are less than 4. If we ask how many numbers are less than or equal to 4, now we know that 4 could be equal to 4, but 3 is less than 4 and 2 is less than 4, and again, so on, we get an infinite number for our answer again. So when we are talking about, well, how do we express this answer? How do we express an infinite number of numbers without having to list all the numbers? That's when inequalities help us express what we are trying to convey. So inequality is just a mathematical sentence, kind of like an equality or a statement that says that two things are equal to each other. An inequality is just stating that two quantities are not always equal to each other. So there are 5 basic inequality symbols that we'll go over. The first one is this symbol. So in order to remember what symbols mean what, just remember that we read left to right. So we've seen this symbol before. The alligator is eating something on the right-hand side. So if we're reading left to right, the alligator is eating the thing on the right-hand side that's bigger. So on the left-hand side is smaller. So we say that this is less than. And so an example would be 4 is less than 6. So this one, the alligator is eating the left-hand side, so the left is greater than the right. So we would say is greater than. So 5 is greater than 3. The next inequality symbol is this. It has an equal sign with a slash through it. And so that is not equal to. So -2 is not equal to 4. Our next symbol looks like this. This looks like the less than symbol, except for it has a line underneath it. So that is saying it's less than or equal to. So -1 is less than or equal to 8. So then the next symbol is greater than or equal to. So 6 is greater than or equal to 0. So our inequalities have what's called a trichotomy. So if you're going to say that, try to do one part at a time. So trichotomy property. And this property says that if you have two numbers, A and B, then one of the following has to be true. Either A is equal to B, A is greater than B, or A is less than B. So the trichotomy property is just saying that one of the following statements, one of the 3 following statements has to be true. Either the numbers are equal, one is greater than the other, or one is less than the other. So an inequality can be negated by putting a slash through it. So if we have x and it has a greater than with a slash in it, 5, then we're saying x is not greater than 5. And if it's not greater than 5, that means it's less than or equal to 5. So we can rewrite that statement. Instead of writing x and then the greater than symbol with a slash through it, we can rewrite it as less than or equal to. So state an inequality statement that is equivalent to not less than or equal to y. So the opposite of not less than or equal to would be greater than. Any value of the variable that makes an inequality true is a solution. So that's what we call a solution to the inequality. Anything that makes that inequality true. So there's going to be an infinite number of solutions typically for every inequality because you should be able to plug in several numbers to make it true. So let's say we have a plus 3 is greater than 6. So we want to find out what are some solutions to this inequality. So if we plug in 2 for A, we get 2 plus 3 is greater than 6. And that's not true. So this is a false. This is 2 is not a solution. If we plug in 3 for A, then we get 3 plus 3 is greater than 6, which is also false. If we plug in 4 for A, we get 4 plus 3 is greater than 6, which is true. So that means that 4, when plugged in for A, is a solution to this inequality. Let's try another one. 6 is greater than or equal to 2 times B. So if we let 2 be B, then we get 6 is greater than or equal to 2 times 2, which is true. If we let B be 3, then we get 6 is greater than or equal to 2 times 3, which is also true because 2 times 3 is 6, and 6 is greater than or equal to 6. It's actually equal to, so it's still a true statement. The next statement is 6 is greater than or equal to 2 times 4, so we're letting B be 4. And when that happens, we get a false statement. So the only solutions and the things that we have tried are the 2 and 3. Let's try another one. 1 minus C is not less than negative 2. So when we do this, the first thing we should do is rewrite the statement. Remember, we can rewrite the not less than as greater than or equal to. So now when we plug in our C values, we just have to test to see if what we get is greater than or equal to negative 2. So we'll start with letting C be 2. So 1 minus 2 is negative 1, and negative 1 is greater than or equal to negative 2. So that's true. Now let's let C be 3. 1 minus 3 is negative 2, and negative 2 is greater than or equal to negative 2 because negative 2 is equal to negative 2. So let's let C be 4. 1 minus 4 is negative 3, and since negative 3 is not greater than or equal to negative 2, that's a false statement. So the only solutions are when C is 2 and when C is 3. So since we have so many solutions for inequalities, we usually express our solutions as a graph on a number line. So if this is our number line and we want to graph it, we can say our graph is a solution. So a circle is used when the number itself is not part of the solution set. So we call that an open dot, just a circle. And that's when the number itself is not part of the answer. So that would be a less than or greater than. Now, if for example, if we have 5 is greater than x, we usually want to rewrite that as x is less than 5. So notice that that's the same statement, it's just that we put our variable first. So that way, when we graph it, it makes a little more sense. So we're going to put a circle at 5 because 5 is not part of our solution. And so our solutions, our x's, all have to be less than 5. So in order to be less than 5, we're going to shade to the left-hand side. Notice that when I rewrite it and I put my variable on the left-hand side, that my shaded arrow matches the direction of my inequality. So let's graph x is greater than or equal to negative 3. So since it can be negative 3, instead of a circle, we're going to put a solid dot at negative 3. And then we want all of these solutions that are greater than negative 3. So that means we're going to shade to the right. Notice again that the arrow matches the way that the inequality points. X is not equal to 2. So we want to put a circle at 2 because the solution has to be greater than 2 or less than 2. It can't be 2. So since 2 is not part of the solution, we'll put a circle there. So we'll put a circle and then our arrows go both ways since it can be greater than 2 or less than 2. So sometimes we want to use inequalities to express something. So for example, let's say that we want a price of an item is going to be more than or greater than $9.99. So everything in the store is either $9.99 or more. We would express this as C is greater than or equal to $9.99. Let's say we want to say that the number of people in the room cannot exceed 225 people. That's the limit. The limit is 225 people in the room. The fire marshal said so. If we wanted to express this as an inequality, we would say P has to be less than or equal to 225. So that's all for this video. Go ahead and try some problems.